We will start this lecture in just 2 to 3 minutes. Let everybody should join. So then after we'll start the lecture. Okay. So kindly wait for 2 minutes. Then we will start our lecture. Okay. Good morning to all of you. I said good morning to all of you.
Morning, sir.
Okay.
Good
Good
morning, sir.
morning. So we are going to start with lecture. Let me share my screen first. Yes, from anyone from you, can you tell me what we have discussed in the last lecture? Can anybody tell me what we have discussed in the last lecture? This is the topic we have discussed in the last lecture. This telephone network and cable TV network for data transmission. Can you tell me what we have discussed in last lecture in this topic? Anyone? Okay, so I need to ask by one. Let me ask by Darshan. Yes, Darshan. Darshan. Open your mic. Darshan, open your mic. Darshan, are you listening to me? Or you are in muted position, your mic and anything is not working right now? Dhanraj, Dhanraj, Dhruvik. Yes, Dhruvik. Dhanraj, no idea. Are you present in the last lecture, Dhanraj? Why? Can you start your mic and speak over there rather than typing the message? Jai Vasavda. Yes, Jai. Can you start your mic and tell me what we have done in the last lecture? Hital Kakkad. Can you tell us what we have discussed in the last lecture? Nancy Balda. Can you tell us what we have discussed in the last lecture? Yes, Syam Makwana says telephone network, switching office and LATA, interlata. Okay, thank you, Syam. Tejas Faldu, can you tell us what we have discussed in last lecture? Tejas, Rusi Goswami, can you tell us what we have discussed in the last lecture? Right or wrong, whatever it is, just speak up. Rusi, you are not giving my answer. I'm continuously asking the question. Even if you are not replying, very few students are replying for the same question. What should I consider? Rusi, yes, switching networks and switching network. Switching network is discussed in the last to last lecture by Shreyas sir. In the last lecture, we have discussed about telephone networks. I don't understand this type of the attitude, man. If you can ask me what you need to do in a in a term work, okay, if you are asking that what we need to do in a rubric on demand, and if I'll just put on silent mode, what you will do? Are you getting any idea? कुछ पता चलेगा कि भाई मैं चुपचाप ऐसे बैठा रहूं, आपको कोई भी बात ना बताऊं? Whatever it is, whether it's right or wrong, please reply कि सर मुझे पता है, ये मुझे पता है, ये वर्ड मुझे याद है, कुछ तो बोलिए. Whatever the stuff you have, please speak up. Otherwise, if everybody is just sitting as a silent mode, whether they are paying the attention or not, I don't know about that. And I'm frankly telling to you that whatever the lecture that I'm going to conduct it over here, it's going to be recorded and it's going to be uploaded in the YouTube. You can attend those lecture anytime from that shared link. And my friend, if you are not asking the question, not solving the doubts, or not participating in the discussion, so you are not going to attend this lecture again in the YouTube also. Okay, and that's not it's going to be any loss, we can say, there is no any type of the disadvantages for me, because I have done my duty. I have recorded lecture and put it for you in YouTube. The loss is done with you only. Okay, you are not paying the attention and not participating in the discussion or in the study. Okay, so whatever it is, I don't mind whether you are giving the answer or not. Some of the students has given the answer 2 to 3. Thank you for their response. Yes, Mukunda says switching in telephone, how switching works from central office. Yes, we have discussed about that, how switching is going to be happen. We have discussed about that how actually the telephone network is going to be work. And if I can say, we have majority time we have given in this particular diagram, like simple telephone service also give you the idea about that, how the data and the voice is going to be handled separately. So such type of the stuff also is going to be happen in your data transfer and signaling network. Okay, so if your BSNL or MTNL will provide you the broadband connection, so whatever the internet access query is handled with the separate network, while the telephone communication or voice communication is going to be handled separately with the other network. So such type of the stuff is going to be happen in the data transfer and signaling network in telephone system. As well as we have discussed about that, that what are the stuff we have in terms of we can say in switching, how that modulation and demodulation is going to be take place, how that bandwidth is going to be shared in that telephone line bandwidth. And we have also done the discussion on that. At a time in the conventional telephone system, at a time only one service you can access, either voice or the data. Okay, so continue from that particular topic. If I'll go with that, like there are the stuff we have, like whenever we are saying that there is a internet access. So in internet access, two stuff we have, like uploading and downloading, which is going to be majority word that you are using during the accessing the internet. So if I can say that, what do you mean by uploading and downloading in particular stuff? So I can say like that, in uploading, what you are doing, like in uploading, whatever the data sequence generating from your PC, which is going past through the modem, which is nothing but modulator and demodulator. So over here, digital data getting modulated in the analog signal. Okay, after that you are uploading something, some information in server. So server is always going to work in the digital data. So what's going to be happen, there are intermediate PCM are there, pulse coded modulation, or we can say analog to digital converter is there. Like that converter will convert the data into the digital. Then through the telephone network, it will reach, or it's routed at the ISP server, and it will, at the end of the ISP server, the data is going to be stored over there. If you can get the reverse idea that about the downloading, so whatever the digital data come from the telephone network, it's again going to pass through the inverse PCM. Okay, so that inverse PCM will convert your digital data into the analog, and from the modem you can get the digital data again in your computer system. So if you are using a 56K modem, there are the different type of the modem is also going to be there. But 56K modem, it's specially applied for, like it's generally applied for every telephone system to uploading and downloading at any particular server. Okay, or in general, we can do this uploading and downloading task. But that analog to digital, digital to analog, such type of the process need to be done before uploading or downloading to that server. Such type of the stuff we have while we are using a telephone for the uploading and downloading something. Next we have, now in previous case, what we have in the telephone line, we are having a problem like that, your data bandwidth and telephone bandwidth both are going to be overlap with each other. So at a time only one service you can access. So we can say after traditional modem reach at their packet data rate, higher packet data rate, we can say the telephone company developed the another technology which is a DSL, digital subscriber link, which is providing high, we can say high speed digital communication over the existing telephone network. Okay, so what are this digital subscriber line and what are their different types of the digital subscriber line, and how it will overcome the issue of that bandwidth overlap, that we need to discuss in this particular section. So we can say ADSL is a asymmetric communication technology designed for residential user, and it is not suitable for business. So for the local communication or for the home use, that ADSL technology is used over there. So what are the stuff is there in the ADSL kind of the technology? ADSL, which is used with the 1.1 megahertz of the bandwidth. So existing local loop has handled the bandwidth up to 1.1 megahertz, and in that 1.1 megahertz, what are the stuff we have? Like in 1.1 megahertz, this is the diagram we have through which that 1.1 megahertz band is going to be generated for data and telephone. But ADSL, which is an adaptive technology, the system uses a data rate based on the condition of the local loop line. Okay. Now, what are this? All these two sentence will tell us. We can understand from this particular diagram. Okay. So, kind of the look properly in this particular diagram. What are the basic stuff we have? We are having one voice channel is there, which is a channel zero. Name is a channel zero. We are having a upstream for uploading the data. We are having a downstream beats for the downloading the data. For the upstream data, we are providing 6 to 30, approximately 24 channels are applied for the uploading data. And from 31 to 255, around 220 channels, 225 channels is applied for the downloading that particular data. Okay. Over that, whatever the voice channel are there, that voice channel directly feed it to the FDM. Okay, now what is a FDM? FDM is nothing but frequency division multiplexing. Okay, so what is going to happen in frequency division multiplexing? Whatever the frequency are coming from one end, all are going to be multiplexed with each other, and it's generating this single communication link. Okay, so in FDM there are 256 channels are there, and each having a size of 4.312 kilohertz. Okay, so we can say whatever the data coming over here, which is having a 4.312 kilohertz, as well as the individual channel which is coming from this separate QAM for upstream beat and from the downstream beat, which is having a 4.312 kilohertz each. And if you can multiply 256 multiply this 4.312, you can get a 1.104 megahertz multiplex channel. So this is the overall picture we have. But what's going to be happen? Let's take, it's a FDM. So in FDM, I think you know about that. In FDM, one master rule should be there. It's a frequency division multiplexing. It means whatever the data coming over here, it must be a analog first. Okay, whatever the data coming over here, it must be analog. If it is not analog, you need to convert it to the any particular process, but it should be in analog over here. Okay, now to make this particular system analog over here your upstream and downstream are in the digital form. Okay, so we are having a digital form data over here, but how we can convert those digital data into the analog? By using a QAM modulator. Okay, which is a quadrature amplitude modulation you have. Okay, so in by using a QAM, what it will do in QAM, like if there is a one you have, so you can get a frequency. If you are having a zero, there is a DC level you have. Okay, it's similar kind of the ASK, but in quadrature amplitude modulation there are the different voltage levels are also there. So according to, it is not simply just 0 and 1, but it is made up of different voltage level. So if I'll go a little bit on QAM, so you can get the better idea. Let me start with this QAM. Yes. Let me bring some of big diagram so you can get the better idea over there. Yes, this diagram we have. Is that visible, everyone? Okay, so
Yes.
what?
Yes, sir.
Okay, so what is happening in QAM?
Yes, sir, it's visible.
Yes, any query? Not visible?
Visible,
Okay.
sir.
Okay. So
It
what
is
happened in
visible, sir.
QAM actually, like you are having, let's take this is an example of 16 QAM. Now in 16 QAM, what you can observe from this one, like you are having a 16 different boxes you have. You are having a 16 different that circles are there. 1, 2, 3, 4, 5, 6. Like it's 8 boxes up, 8 boxes down. Okay. You can say like that there is a 16 box are there, or we can 16 circles are there, or 16 points are there. So each point can be represented with the 4 bit of the binary data. You can observe over here 00000001. Likewise, there is a 16 possibilities represent with these 16 different binary data. Okay, and what this particular animation will show it to you, like whenever there is a data which is going to be accessed through this QAM diagram, you can say that 1100, which is accessed with the 25% of the amplitude and 225 degree of the phase. So where is we have 1100? Yes, we have 1100 over here. So 1100, which is identified by 225 degree. You can say from starting 0 to this is a 225 degree, and amplitude is going to be 25%. Okay. Similarly, 1001, we can say 1001, which is situated over here. So we can say which is identified by the 135 degree of the phase. Like you can say this point is having a 135 degree from the origin. So you can say like that there is a 135 degree, and what is amplitude? This is a 0.25. We can say this is going to be 0.75. Okay, so we can say 0, you can say like that 0, 0.25, 0.50, 0.75. Likewise you can define, but at the starting from this particular point, this 1001 can be represented with the 75 percentage of the amplitude. Okay, so each and every 4 bit of the sequence can be represented with the two quantity. Which two quantity? Amplitude and the phase. Okay, so if I can say there is a 16 QAM, so there are a bunch of 4 bit you are transmitting continuously. Okay, you are transmitting 4 beats simultaneously, and that 4 beat going to be represented with the individual amplitude and individual phase. That is the meaning of QAM, quadrature amplitude modulation with 16 points. If there is a 32 point, then 16 points are here, 16 points are here. And what is the size of data then? What is the size of the data in 32 QAM? Over here there is a 4. If there is a 32 bit, 32 QAM, then how many beats are there for each and every circle? Can anybody tell me? Right now there is a 4 bit we have, so we can take the 16 QAM. If I'm having a 32 QAM, then how many kind of the beats are representing in each and every circle? 5. Yes, Mukund is saying 5. It's completely right. So 5 beats are there for each and every circle. Okay, so in each and every circle there are the 5 beats, and there are having a different phases assigned for that, as well as there is a different amplitude is assigned for that. So likewise, such type of the QAM we are applying over here for that particular modulation of that particular data. Okay, so what we can say, 15 beats per board we have. Okay, 15 beats per board. We can say right now we are applying, that is a QAM with the 15 beats. Okay, per board. We can say there are a group of 4 beats are there, which is going to be assigned over here. or you can in general you can take a reference like that. If you are having a 15 beats over here, okay, in a particular board is nothing but we can say there is a group of symbol. So we can say one group of symbol is made up of the 15 beats. So we can say there are a different QAM technique which is applied over there. If that number of beat is going to be changed over here, then that QAM, that different QAM is applied over here. But what is a condition we have, like it should be having a 4.312 kilohertz signal over here. As well as you can see there is a serial to parallel and parallel to serial converter is there. Over here there is a serial to parallel converter. Why? Because you are sending the data, so that data is going to be serial over here and it's going to be converted parallel over here. Likewise, you are downloading the data, so your available data was digital and you are accessing those data. That's why it's a parallel to serial converter you have. Okay, so such type of the stuff you have in a serial to parallel and parallel to serial converter type of the stuff. Now apart from this particular question, can anybody tell me which particular device is responsible to convert from serial to parallel and parallel to serial? Can anybody tell me the answer? Which particular device give you the serial to parallel and parallel to serial converter? You have seen such type of the circuit in a digital communication in last semester. Can anybody tell me which particular circuit? Yes, yes. Hello. Yes, who is speaking? Please give me the answer.
Sir, flip flop.
Yes, definitely. Like there is a flip flop, and if you have heard about that, there is a serial to parallel, or you can say serial in, parallel in, serial out. Such type of the register you have heard in the last semester. Okay, so that serial in, parallel in, serial out is nothing but this is a serial to parallel and parallel to serial converter you have. So over here, that flip-flop based circuit is going to be applied over here to identify the serial to parallel converters beats or parallel to serial converter beats. Okay, so digital communication is applied over here. Good answer. Uh, Thank you for your response. So as we have discussed, we are using a FDM over here. So we can say there are the frequency band of 1.104 megahertz you have. So by looking to this particular segregation, looking to this classification, if you can plot their frequency response diagram, so bandwidth is going to be divided in such type of the manner. Like 0 to 4, there is a voice signal is going to be there, as well as from 26 to 108 there are the upstream frequencies are there. It means in this particular band only the uploading of the data is going to travel with this particular frequency, while for downloading it's starting from 138 to 1104. So we can say in previous case in normal telephonic system what we have, in normal telephonic system we are having a overlapping of the data with each other. Okay, like that all this stuff is going to be overlapping, voice and data, all stuff. But now in modern ADSL technology, what are the advantages we have? Like voices travel with this separate frequency, upload also travel with the separate frequency, and download services also run with these separate frequencies. So such type of the separate frequencies are there, so overlapping is going to be removed over here, and we can also do this task simultaneously. We can upload also, we can download also, we can do the voice communication also simultaneously. So this is a main advantages we have for this particular ADSL technology. Any doubt, any problem till now? If you have, then you can ask me. Any doubt, any question till now? Okay. So we can start with the, let's take, there is a ADSL, we have seen that there is a ADSL is there, in which there is a voice is going to travel separately, their data is going to be travel separately, but how it is going to be possible to identify that particular voice and data separately? So for that, simply we required one splitter. Okay, so whatever the data coming from the network, simply by putting a splitter and having a two component in the splitter, low pass filter and high pass filter. Why there is a low pass filter? Because over here voice is coming with the low frequency. Well, why there is a high pass filter? Because data is coming with the high frequency starting from 26 to 1104. So by setting a low pass filter of 0 to 4 kilohertz and by setting the filter of 26 to 1104 kilohertz, you can separate out voice and data separately over here. So voice directly, it's analog signal, so you can directly feed it to the telephone device. But the data is coming right now in terms of analog, but you required that data should be converted into the digital, then it is going to feed it to the we can say PC. So for that we require ADSL modem, which will again do the demodulation of that analog system, analog signals, and then it is give the proper data in your computer device or any particular kind of the networking device. Okay, this is a ADSL modem when we are receiving something, as well as when we are sending something. Let's say whenever we are sending this data to the network, so similar we need to do that from the local loop. If you are sending this data to another network, like we know that there is a diagram like telephonic system is going to be handled separately, while internet access is going to be, or data network is accessing separately or handled separately, as we have discussed in the last lecture. So we can say whenever we are sending to that particular telephone network or to the internet, again we are applying a low pass filter and high pass filter to separate out voice, which is going to be handled by the telephone network, and the another high pass filter that we are having going to be packetized data. And there is a DSLAM, so we can digital subscriber, like we can say it's another modulator stuff we have, which actually packetize your data. Okay, and then it is sent to the internet. It means that you are one user, you are having some downloading queries there, you are having some uploading queries there. So all this stuff going to be packetized in one particular through the one particular system, and then it is thrown to the internet. Like this entire packet is designed for this particular person. So you are having your ID, IP address, all type of the stuff you have. Okay, but before sending to the internet, it's converted to the packetize. It's done the packetization, and then it is sent to the internet where the only data is going to be handled. Okay, so such type of the stuff is also going to be happen when it is come to the, when it's come directly towards the, we can say sharing with telephone network and sharing to the internet. This is one of the comparative analysis there. Like this is a DSL, there are lots of stuff are there. There's asynchronous DSL, asynchronous DSL lite, there are the different versions are there, but that technique is going to be same. We need to do the such type of the stuff. We need to we are going to handle the voice and data separately. But as the technology is going to be changed, you can see over here their upstream data, the downstream data, and all type of the stuff is going to be changing over here. You can see in ADSL it's 1.5 to 6.1 Mbps in downstream, while in upstream rate is going to be 16 to 640 kbps. So such type of the kbps rate is going to be there, depend upon the distance that you can use. And there's a line coding technique, DMT 2B1Q, so that all line coding, or similar to that line coding NRZ Manchester, okay, biphase Manchester, you have already discussed in the very kind of the previous lecture. But over here the topic of discussion like that depend on the technology change. You can say there are the downstream, upstream, the data rate going to be changed, that allow we can say kind of the maximum distance that you can achieve with that, which is going to be changed over here, and types of the twisted pair cable, which is also going to be changed, or we can say it's going to be remaining for some of the technology, but it's going to be changed in some of the technology. So this is a comparison depending upon the requirement of your downstream rate, upstream rate, and distance, different type of the technology used in the digital subscriber link. But main motive over here, the digital subscriber link is used to separate out or to handle their query of voice and data separately. This is a main stuff we have over here. Yes. Next up that we are going to discuss, which is going to be a cable TV network. Okay, so in the cable TV network, uh, you can also relate it with the service provided by the GTPL or DAN, or previously it is provided by the any local company. Right now that cable TV network is totally changing from the as per the Digital Transmission Act will came. And in Digital Transmission Act, already that cable TV operator also adopted the digital transmission, as well as there is another companies like Tata Sky and Videocon. Okay, there another companies are there which have given the directly video streaming through the satellite communication. Okay, but we there is another part of the satellite communication in terms of television broadcasting. But right now we are discussing about the cable TV networks. Okay, so in cable TV networks, as the video service provider, but it has moved to business of internet access also. Like cable TV network, like GTPL also provide you the internet access also through that cable connection only. Okay, so we can say how this both stuff is going to be separate out, and how that high speed internet access is possible through the cable TV network. Okay, so what is a traditional cable TV network? You can relate this particular diagram with your kind of the nearby cable TV operator. Like you can say like that there is one, it's like there is a GTPL in the Rajkot. So in GTPL in Rajkot, they have one office, and in that at the top of that office they have the big size of the parabolic antenna. There such type of the dish antenna are there, very big size. What they are actually doing with this antenna, so from the satellite, so for that before understanding this cable TV network, you need to understand like that we are having so many channels are there. Okay, like there is a Z Cinema, Z TV. Okay, there are the several channels are there. So if you can consider like that overall picture, that whatever the companies are there, different companies, like I can say Sony TV or Z New or Z TV. So we can say there are the companies are there, which companies which will first of all merge all their channel at one particular location, like whatever the different channels given by the Z company. So that company will first bunch all the channels, and then that channel is going to be transmitted through one particular antenna through the satellite. Okay, they are transmitting through the antenna, and it is reached at the satellite, which is already kind of the launch by the government of India, or by the kind of the association with the government and with that private body. So after launching the satellite, this that service provider, that Z TV kind of the company holder, or their particular kind of the location, they are having a big size of the dish antenna are there, and from the dish antenna they will send the bunch of the channels to the satellite. And from the satellite there are a different uh, cable TV operators are there, like DAN, GTPL, another cable TV operator. They will have the license to access those channels. So what they will do, from their antenna at the top of their roof, they will get those channel at their particular end, or at that particular geographical location. If I can say it's at the Rajkot, so they will receive those channel in the Rajkot. If GTPL already available in Ahmedabad, so they can also access those channel from the Ahmedabad. Now there is a different company sending their channel to satellite, and GTPL is accessing those all channel at their end. Okay, you can also see there are the lots of antennas are there. Okay, so it's not going to be like there is only one antenna, which, or we can say one satellite which is doing this particular TV broadcasting. There are the multiple antenna which doing the broadcasting with the different kind of the channels. So by taking all the channels from the satellite, what this cable TV operator do, they will merge or multiplex all the channels, okay, at their particular area or at that particular level. After the multiplying all the channels, or we can say after multiplexing all the channels, they are having one common cables are there. We can say there are a big high speed capacity of the coaxial cables are there, and that coaxial cable is going to be travel with the different intermediate amplifier. Like let's take this office is situated in kind of the outskirt of the Rajkot. So from their location to the city area, they will distribute this particular cable. Okay, and whenever there is amplification required, they will do the amplification, and when it is reached to the any society or at any particular location, there are a power splitter are there. Power splitter is nothing but there is a one type of these cable separator. Like if you can give the one cable, so whatever the data inside the one cable, which is divided into the half of the power, and then it is given to the two different location. Like I'll give you the simple example like that. If from your kind of the roof, if one cable connection is going on, and if you can just cut those cable connection, and if you just take if you have subscribed for the GTPL at your home, so what they will do, they will simply put a tap connection. Tap connection, it means they will put one drop cable over there, and from the drop cable you can directly take the channel from that GTPL cable. So this is going to be happen at the splitter also, and the same thing is going to be happen at the drop cable also. So what they will do, from your television set to one another coaxial cable is there, which is connected with the main coaxial cable, and you can get the whatever the channel which is subscribed by this particular that particular service provider, you can see over here. Now, if you have remember this stuff, if you are having a cable TV network, before getting this cable TV network, and if before getting starting this particular services, first you need to set up your television for the reception of that particular channels. So if you have remember in old age time, and if you have any thought over there, and so there is one fine tuning, there is a section is there. So if you are receiving any channel through the cable TV, you need to do the fine tuning or channel tuning. So whenever you are doing a channel tuning, what is going to be happen automatically that different channel is going to be set at the different number of your particular register. Like we can say, if there is a GTPL, and if there is a cable TV network, and if they are successfully getting the Z cinema, okay, and Z cinema having a proper power over here, there is no interference, properly receiving channel. So you can say 121 number which is going to be assigned during the tuning process of this particular television set. Okay, so once you will tune your kind of the channel, then you can get those all the channels at your particular doorstep. Okay, but it is going to be happen like that, this speaking antenna not getting the Z cinema properly, it having a lots of noise, then what's going to be happening during the tuning of the television set, you are not getting that channel from your doorstep. So you can get the query like that, I cannot receive the Z cinema over here. Why? Because it's not received by the main antenna. So such type of the problem is going to be happen, that particular government has regulated, like you can, or you need to separate out that much of the customer only with this single cable. But what that different service provider will do, they will just increase the number of users over there. So overall company cannot identify that how many actual users are connected with my channel. So for that they have adopted totally new technology, which is a direct to home service, DTH, that we are saying right now. Okay, so these are the stuff we have from history to modern day kind of the transition. But this stuff is going to be happen in a traditional cable TV network. If you have any doubt over here, or if you want to discuss more in this stuff, you can ask the question right now. You can open your mic and you can ask me the doubt if you have directly. Don't write in a chat box, because I need to shift from that. You can open your mic and you can ask me directly.
Hello, sir.
Yes, please.
Sir, ADSL modem પાછો કહેજો.
ADSL modem. Okay, this one. Okay, this one.
Yes, yes.
Okay. So in ADSL modem, first you need to understand this diagram. Have you understand this diagram? That voice upstream,
Yes,
downstream, which is going to
yes.
be done separately. Now in ADSL modem, what's going to be happen? Like you know that from this frequency response, that your voice is situated between 0 to 4 kilohertz, and your data related information is situated from 26 to 1104 kilohertz. Okay, so what in ADSL module do, that ADSL module will put one low pass filter which is size of this particular yellow box. okay, and high pass filter of the 26 to 1104 box. Okay, so by putting the two filter, low pass filter and high pass filter, you can separate out voice as a kind of the individual quantity, and data is an individual quantity. So this is thing is going to be happen over here when you are having a single cable you have. Okay, if you are accessing the internet through any particular network, telephone network from the local loop, if you are having only one cable, so that one cable is connected in the splitter, and splitter having a two component, low pass filter to separate out the voice and high pass filter to separate out the data. Okay, so from the single cable, by putting this one particular box, you can separate out your voice and data separately. Why it is possible? Because already data is transmitted like this frequency distribution. Okay, it's already transmitted with this distribution, so that by applying the filter you can also separate out that same thing again. Okay, so what is happening over here, you are multiplexing over here. Okay, and you are separate out it over here by putting a different type of the filters over here. That's the stuff we have, and that is the main advantages over the conventional system. Like in conventional telephone, data and voice are going to be overlapped with each other, so at a time one stuff you can access, but in ADSL you can access both of the stuff simultaneously. Why? Because they are transmitting with these different, or we can say individual band. This is the stuff in ADSL modem. Am I clear with this stuff, or still I need to? You have any query or doubt in this one? Any question?
No, it's clear.
Okay, done. So if I can go with that cable TV network and the advancement in the cable TV network, that we can hold on a second. Okay, so if we are having a hybrid fiber coaxial network, like we can say, if the number of users is going to be increased in your, we can say cable TV transmission, if number of users is get increased, so what are the stuff is going to be happening over here, that you need to use a different type of the cable that can accommodate a more number of user in a cable TV network. So what their particular change in that high speed, or we can say in a large quantity of the we can say that accessing customers are there. So for that they have changed their coaxial cable into the fiber optic cable. Okay, so what they will do, whatever the data coming generating from that center of that cable TV operator, the data is converted to the light, and it's transmitted through the optical fiber. And you know that in the initial chapter we have learned about that in optical fiber you can access the data very fast, as well as you have the large size of the bandwidth, because it's operating in the terahertz. So there is a large bandwidth is also there, there is a speedy communication is also there. So by providing the fiber optic cable and the appropriate amplifier for that at your location, like if this is situated at the center of your city or at the outside of the city, when it is reached to your society or your location, again it's going to be converted from optical to electrical. There are one fiber node are there, or we can say there are the optical to electrical converters are there, and through that intermediate device that signal converted to the electrical, and then it is going to be reached to the door to door. Okay, so to increase the number of customer, to increase the bandwidth, or to increase the speed, that hybrid fiber based we can say cable TV network is also possible to achieve the high speed TV transmission, as well as a large number of users you can accommodate with that. Okay, so such type of the stuff is going to be modified when we are using a fiber coaxial network. So this is just to increase the speed and increase the bandwidth. Like if number of channel is getting increased, like right now I can say GTPL is providing a HD TV also. So we can say with the conventional coaxial cable, HD TV transmission is not going to be possible. So what they will do, they will first install the fiber optic cable near to your location, and from the fiber optic cable they will give you the coaxial cable connection to access the HD television services. Okay, so that's why this modification is required in the cable TV transmission. So communication in the hybrid fiber kind of the system, cable TV network is going to be bi-directional. Like this is the main advantages we have. Like in previous case, there is a unidirectional stuff we have. Like whatever the channel you are receiving, that's it. You cannot do anything in reverse. But right now, whatever the digital subscriber link you have with the cable TV operator, I'm talking about not about the Tata Sky, not about Videocon, but GTPL provider will give you the one particular box, and they will give you the services like choosing the channel, okay, accessing some special services, okay, like kind of the tuning some different channel according to that. So such type of the stuff will also provide a bi-directional communication also. Okay, so this is the main advantages if we have gone with this hybrid fiber based network. Now another stuff we have, like if there is a same cable TV network is, or we can say cable TV system is applied for the data transfer, then how it is going to be happen, which is possible to do the bi-directional communication. So cable companies are now competing with the telephone companies for residential customer who wants to high speed data transfer. And in this we need to discuss about the stuff which is related to the data transfer using a cable TV. So this is the stuff we have, like division of the coaxial band in normal TV broadcasting. Okay, as well as it is having a upload and downloading dedicated band is also there. So we can say like that in a megahertz frequency, in dedicated megahertz frequency, we can see like that 5 to 42 megahertz is applied for the data upload. We can say data upstream. 54 to 550 is applied for the video broadcasting, or we can say for the television kind of the purpose, and 550 to 750 is applied for the downstream also. So simultaneously if you are accessing the television also, simultaneously if you are accessing the data transmission also, so this is going to be separate out with 5 megahertz to 750 megahertz of the band, similar as a telephone network, but over here like in telephone we are having a telephone communication is there. Right now one band is dedicated for the video over here because this is a cable TV network. So in cable TV, separate band for the video, separate band for the upstream, separate band for the downstream. Okay, so we can say you can do simultaneous work, you can download, upload, you can see the video, all the stuff is possible with this particular division of the coaxial cable. So downstream data is going to be modulated with the 64 QM modulation technique. We already know that 64 QM having a 32 boxes is going to be in upside, 32 points are in upside, 32 in downside. All points will represent different amplitude as well as the different phase. Okay. While theoretical downstream data rate is going to be 30 Mbps. So you can download maximum up to the 30 Mbps speed, and upstream is going to be modulated using a QPSK modulation technique. Okay, so we can say there are the downstream with the 64 QAM modulation technique, upstream with the QPSK modulation technique. Okay, and it's the upstream is maximum goes up to 12 Mbps. So downstream with the 30 Mbps, upstream with the 12 Mbps. How it will look like? So you are having one filter are there, as we have discussed in telephones. Similarly, we are having a filter for separate out the video and separate out the data. So from the cable, from the coaxial cable, you need to tap that particular cable, or you need to interconnect your coaxial cable which is come to your home. There is one filter are there, band pass filter for the video. Now what is the range of that band pass filter of the video? Which is having a range of 54 to 55. Why in the 555 to 750 and 5 to 42, this is a band pass filter for the cable modem or for the data communication. And we know that this is a cable communication, so all the data is going to be happening in a analog transmission. We have done the modulation with QPSK and QAM, so we can say output data is going to be analog. So we are also receiving the analog signal over here. So video directly fed to the television because it's required the analog type of the information. But before getting this signal through any computer, we need to convert that analog data again with the digital. So we are having a 64 QAM demodulator are there, as well as QPSK demodulator are there for the retrieving upstream and downstream over here. Okay, so this is a cable TV operator we have, and these are the stuff. That last diagram we need to discuss. If we are having a fiber, if you are having a fiber cable modem transmitter system, what we can say for the fiber, like this diagram, similar to that we have discussed in that telephone network, like you are accessing the fiber also to take the high speed data communication. So what's going to be happen whenever that separate, like internet is handling separately, as well as video is also going to be handled separately. So what are the stuff over here, that video and data all going to be combined, and combinedly it is converted to the optical signal and received to the and send it to the fiber. And whatever the fiber, it's a bidirectional kind of the system we have. So whatever the data coming from the fiber, so first it is go to the one particular CMTS device, cable modem transmission system device, then it is do the bidirectional communication with the internet. Okay, so whatever the data coming from the fiber, it is going to be accessed, or it's going to be shared there with the internet, while in the video, which is only a one directional communication, so it's gone through the combiner and feed it to the fiber. So we are not having that enough time. We are having only 2 minutes over here. So again, we will start with the same discussion. We will revise that in the next lecture. But right now, if you are having any doubt, any question, you can ask. You can write down your enrollment number also, your roll number also. And if you are having doubt, you can ask in this 2 minutes. And those who have not any doubt, they can leave the meeting and wait for the next lecture. If you have any doubt right now, you can ask. We are having a 2 minute of time to address your doubts. Don't worry if you have not understood anything. Again, we will start with this particular session, and then we will move forward for the another kind of the topics.
सर
Yes.
सर मिड टाइम में किधर तक आएगा?
Actually, in DCN, you are not having any mid sem. We are having a unit test 1 and 2. Okay. ये कैनवास वाइज सब्जेक्ट है, तो ये डिपार्टमेंट लेवल पे आपकी एग्जाम है वो कंडक्ट की जाएगी, और उसमें आपको शॉर्ट क्वेश्चन और एमसीक्यू, टू टाइप ऑफ द क्वेश्चंस आर देयर व्हिच इज गोइंग टू कंडक्टेड इन कैनवास. ओके, वो हम सब आपको गाइडलाइन सब प्रोवाइड करेंगे. लेकिन ये जो रेगुलर मिड सेम अभी हो रही है, उसके साथ हमारा डीसीएन का एग्जाम नहीं होगा, व्हिच इज कंडक्टेड सेपरेटली ऑन कैनवास. ओके, सो वी विल गिव यू ऑल द डिटेल्स ओवर देयर. So you continuously visit the Canvas portal.
Okay.
Sir, fail to send आ रहा है.
Okay. Let me write down your number. Yes. What is your number?
CE84.
CE
84.
CE84. Okay. Then any other having?
Hello, sir.
Yes.
CE 106.
Yes. IT
4.
IT 04. Then
IT
CE 106.
CE 106.
So
Then
IT 03.
IT 14. IT 03. Anyone else having
CE80.
CE80? CE80?
Yes, sir.
Okay. Any other students? Issues in attendance?
सर
Yes.
सर स्प्लिटर यूज करने से अपना कनेक्शंस के लिए स्प्लिट हो जाएगा?
कनेक्शन स्प्लिट? हाँ, कनेक्शन स्प्लिट ही होगा ना, क्योंकि दो सेपरेट केबल होते हैं.
नहीं सर, कनेक्शन स्पीड
यहाँ होता ही है ना, क्योंकि एक वो आपका 4 kbps पे है, और दूसरा है वो mbps में है, वो भी सेपरेट ही हो जाएगा ना, क्योंकि उधर देयर इज अ बैंड इज देयर. सो बैंड में जितना स्पीड का वो डेटा मैक्सिमम रहता है, वहां तक ही आप जा सकते हो. लाइक आपके पास 4 kbps है, तो आप kbps का आप कंसीडर करो तो उतने kbps की स्पीड ही आप अचीव कर सकते हो. आप kbps के चैनल पे gbps तो नहीं कर सकते हो. So if the data is reached at the higher frequency, so data rate is also going to be different, speed is also different, definitely. Is it okay?
Yes, sir.
Okay.
Okay, thank you, sir.